the function f of x is equal to mod cos x as a Fourier series in minus pi less than x less than pi. This is the interval. Okay, the function is f is equal to mod f of x. So solution, f of x is equal to mod of cos x. See, f of x is equal to mod of cos x. Mod of cos x means it is a even function. So if it is even function, automatically bn value is 0 because the f of x is even function. Since f of x is even function, now we need to find a0 value and an value. See, if we observe, the limits are minus pi to plus pi. So Fourier series f of x formula, f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx. So here we have to find an and a0 and an. a0 is equal to, formula is 2 by pi integral 0 to pi. See, here the given integrals are negative to positive. So if the negative to positive, it is even function, so we must write 2 by pi integral 0 to pi f of x. F of x means this is the f of x. So mod of cos x dx, that is equal to, see here the integral are 0 to pi, so we have to use this formula here. Integral a to c f of x dx is equal to integral a to b f of x dx plus integral b to c f of x dx. See here 0 to pi, we have to split this 0 to pi, that is equal to a0 is equal to 2 by pi integral 0 whole into integral 0 to pi by 2. See, 0 to pi by 2 to pi, so we have to split 0 to pi by 2 to pi. So 0 to pi by 2 mod cos x dx plus integral pi by 2 to pi mod cos x dx. See, this is pi by 2 to pi. This is the second quadrant. In the second quadrant, cos is negative value. So 2 by pi into integral 0 to pi by 2. This is cos x dx plus integral pi by 2 to pi. Here is negative cos x dx. Since in second quadrant cos has negative value, that is equal to 2 by pi integral of cos is sin x, where 0 to pi by 2, this is plus into minus minus, integral of cos again it is sin x pi by 2 to pi, that is equal to 2 by pi into substitute upper limit in x place minus lower limit. Okay, sin pi by 2 minus sin 0, this is first one, negative of, here also same apply the same thing, sin pi minus sin pi by 2, that is equal to 2 by pi into sin pi by 2 is 1 minus sin 0 is sin 0 is 0 minus again sin pi value is 0, minus 1. That is equal to, see, this is minus into minus plus 2 by pi into this is 1 minus into minus, this is minus into minus plus 1, so it is 2. That is equal to a naught value is equal to 2 by pi into 1 plus 1, that is equal to 2 into 2, 4 pi. This is a naught value. Now find an value. An is equal to, formula is 2 by pi integral 0 to pi f of x cos nx dx. Here f of x is, substitute the value, that is equal to 2 by pi integral 0 to pi mod cos x into cos nx dx. See, again here also 0 to pi, so apply the same formula, split the integral, so split the limits, 0 to 2 by pi, so 1 by pi into integral 0 to pi, take it to internal, so 2 into mod cos x into cos nx dx, that is equal to 1 by pi into integral 0 to pi by 2, 2 into mod cos x into cos nx dx plus integral pi by 2 to pi, 2 cos mod cos x into cos nx dx, that is equal to 1 by pi into, see, this is 0 to pi by 2, first quadrant cos is positive, so integral 0 to pi by 2, 2 cos x into cos nx dx plus, this is pi by 2 to pi, in this is second quadrant, in the second quadrant cos is negative, so integral pi by 2 to pi minus 2 cos x cos nx dx, since in second quadrant cos is negative. That is equal to, now this is 2 cos A cos B, so 1 by pi into integral 0 to pi by 2, 2 cos x into cos nx dx plus into minus integral pi by 2 to pi 2 cos x into cos nx dx. See, observe, this is 2 cos A cos B formula, this is x, it is nx, so it is b, it is a, so 2 cos A cos B is equal to cos of A plus B plus cos of A minus B. You know that A is equal to x and B is equal to nx. Substitute in the formula, that is equal to B values in the formula, that is equal to 1 by pi whole into integral 0 to pi by 2 cos of A plus B, A is equal to x plus nx, B is equal to nx plus cos of x minus nx, this is the first one, minus integral pi by 2 to pi cos of x plus nx plus cos of x minus nx into dx, this is the second one. Here that is equal to 1 by pi whole into integral 0 to pi by 2 cos, here we can, any x is common, 1 plus n into x plus cos of 1 minus n into x, here is dx into dx minus integral pi by 2 to pi cos of 1 plus n into x plus cos of 1 minus n into x into dx, that is equal to 1 by pi whole into integral 0 to pi by 2 cos of 1 plus n, we can write n plus 1 into x. See, 2 plus 3 is equal to 3 plus 2, like this. So plus, and cos of here n minus n plus 1 into dx into dx minus integral pi by 2 to pi cos 1 n plus 1 into x plus cos of minus n plus 1 into x into dx, that is equal to 1 by pi whole into, split the integration, integral 0 to pi by 2 cos of n plus 1 into x dx plus integral 0 to pi by 2 cos of, here is minus common, so minus of n plus 1, so n minus 1, here minus, here is plus, taking minus common, minus plus n, the symbols are reversed, so it is plus, it is negative, to x dx minus of cos of n plus 1 into x dx, here integral is pi by 2 to pi plus integral pi by 2 to pi cos of, here also minus common, minus of n minus 1 into x into dx. See, we know that cos of minus theta is cos theta, so here is cos of minus theta is equal to n minus 1. Before that, this is a 1 by pi whole into integral 0 to pi by 2 cos of n plus 1 into x dx plus, if we apply here, this is also integral 0 to pi by 2 cos of n minus 1 into x dx minus g pi by 2 to pi cos of n plus 1 into x dx plus, here also same formula, integral pi by 2 to pi cos of n minus 1 into x dx. See, we know that integral of cos ax dx is equal to sin ax by a plus c. But if we compare every integral has cos, so a is equal to here n plus 1 and another one a is equal to n minus 1. Substitute here, that is equal to 1 by pi whole into, this is sin n plus 1 into x by n plus 1 plus sin of n minus 1 into x by n minus 1. The limits are 0 to pi by 2, negative of, here also same, sin of n plus 1 into x by n plus 1 plus sin of n minus 1 into x by n minus 1. The limits are pi by 2 to pi. Now observe here, now substitute upper limit in x place and lower limit in x place, as well as upper limit in x place and lower limit in x place. If we observe here, lower limit is 0. We know that sin of n into 0 is equal to 0 and sin of n into pi is equal to 0. If we observe here, the lower limit is 0. Sin of this total, assume n into 0, this is 0. This is also 0. Here lower limit is 0. Here pi, upper limit value 0. That is equal to 1 by pi. The upper value is sine of n plus 1 into pi by 2 by n plus 1 plus sine of n minus 1 into pi by 2 by n minus 1 minus lower limit is 0 because lower limit is 0 minus here also upper limit is pi. So upper limit when we have sine and pi is equal to 0. So upper limit 0 minus lower limit is sine of n plus 1 into pi by 2 by n plus 1 plus sine of n minus 1 into pi by 2 by n minus 1. That is equal to 1 by pi whole into, now this is multiply with pi by 2, n into pi by 2 sine of n pi by 2 plus 1 into pi by 2 pi by 2 by n plus 1 plus here also multiply with pi by 2 sine of n pi by 2 minus pi by 2 by n minus 1. So minus 0 need not write 0, minus into minus it is plus. The next sine here also multiply with pi by 2 sine of n pi by 2 plus n pi by 2 by n plus 1 plus sine of n pi by 2 minus n pi by 2 pi by 2 by n minus 1. That is equal to 1 by pi. This is 2. Here is n pi by 2 plus pi by 2 sine, and here also same. So 2 sine of n pi by 2 plus pi by 2 by n plus 1 plus here also this and these are same. These two are same and these two are same. So here also 2 sine of n pi by 2 minus pi by 2 by n minus 1. See, this is sine of theta plus pi by 2 is equal to cos theta, whereas sine of here minus common, minus is common, so pi by 2 minus theta is, that is equal, before that it has negative value, minus sine of pi by 2 minus, that is equal, sine of pi by 2 is minus cos theta. So that is equal to 1 by pi whole into, this is 2 cos of n pi by 2 by n plus 1 minus this is 2 cos of n pi by 2 by n minus 1. See, here is 2 cos n pi by 2, here is 2 cos n pi by 2 is common, taking common 2 cos n pi by 2 by pi, it is common, the remaining is 1 by n plus 1 minus 1 by n minus 1. See, here is denominator n plus 1, here is denominator l plus 1. LCM is 2 by pi into cos n pi by 2. Here LCM is n square minus 1, cross multiplication n minus 1 minus of n plus 1. That is equal to 2 by pi cos n pi by 2 into n minus 1 minus n minus 1 by n square minus 1 plus n minus n cancel. It is 2 by pi cos n pi by 2 into this is minus 2 by n square minus 1. That is equal to, see, 2 2s are 4, it is minus 4 pi n square minus 1 into cos n pi by 2. This is the a in n value.
Now if n is equal to odd value, this n is equal to odd value, n is 0 where n is not equal to 1. Next, n is equal to even and an is minus 1 by pi into n square minus 1 into minus 1 to the power of n by 2 plus 1. So here we have to use this one. So Fourier series f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. Substitute a naught value is 4 by pi, and this is an. Substitute these two values in the formula. 4 by pi by 2. Before that, f of x is cos x plus summation n is equal to 1 to infinity an value is 1 by pi into n square minus 1 into minus 1 to the power of n by 2 plus 1 into cos nx. This is the expandation of Fourier series of given function.